A block performs SHM on a frictionless surface with a frequency nu naught. The block carries a charge of plus q on its surface. If now a electric field of E is switched on as shown, then the SHM on the block will be equal to, first of all, let us assume that the electric field is not switched on. Okay, electric field is not switched on. So initially there will be a block. Okay, initially there will be a block and there will be a spring. Let us say the mass over here is equal to m. Okay, and the charge over here is equal to plus q, but this charge will not affect the this will not affect the frequency or anything, amplitude in any case. Okay, so over here let us say the velocity over here is equal to v. Okay, the velocity over here is equal to v. Now omega is equal to root of k by m. Okay, which depends on over here, which depends on k is the spring constant and m is the mass of the block. Okay, let us assume that this is moving on a frictionless surface. Okay, when I apply a electric field E, when I apply an electric field E, there is an additional force acting on the block. This additional force will be equal to, first of all let me consider that this is the mean position, this was the original mean position over here. Okay, so over here this was the original mean position. Okay, so when it is moving in the right hand side direction, it will experience a force in the left hand side direction. So this force will be equal to force due to the electrostatic force, plus over here it will be equal to the force over here will be equal to kx. Okay, the force over here will be equal to kx. Okay, now the kx will be positive or negative depending on the value of x. Okay, let this x over here be equal to 0. But in the second case, omega will still be equal to root of k by m. So there will be no change in the frequency. Frequency will remain same. But if I consider the point at which, okay, the point at which, let us say it was moving with this amplitude, over here. Okay, it was moving with a certain amplitude. Okay, now the amplitude, how is the amplitude obtained? Okay, now amplitude will be f will be over here will be equal to m a, which can be written as f is equal to, now the amplitude can be written as when I can say that when the a is max over here, which will be equal to omega square a. Okay, which will be omega square a. Now the omega remains constant and the m remains constant, so I can say the amplitude will be equal to the force applied. Now initially the force applied was just equal to kx. Now the force applied will be equal to fe plus kx. So amplitude will change. So the amplitude will change, or the mean position of the amplitude will change over here. Okay. So now I can say that. The body will move with the same frequency but a shifted mean position, which is equal to option number A.